Hey everybody, 6.4 is the lesson that you are watching right now. And we're going to talk about the mid-segment of a triangle and what's called the triangle mid-segment theorem, and then practice some of that. So first off, some vocab. The mid-segment of a triangle is a segment that connects the midpoints of two sides. So remember, you can always pause this if I'm going a little too fast for you. All right, let's look at the theorem here. So theorem 6.8 says it's a triangle mid-segment theorem, and it reads, the segment connecting the midpoints of two sides of a triangle is parallel to the third side and is half as long as that side. So in this situation, it says DE is the mid-segment of triangle ABC, and also DE is parallel to AC, and DE is half of AC. So what does this mean? First part is that you need to know that mid-segments are parallel to each other. Sorry, not to each other. The mid-segment is parallel to the the side that is almost like a base. So if I look at this triangle over here on the side, AC is not technically a base. But if you want to look at it, sort of like the mid segment, which is DE, is parallel to AC, which looks like a base. Okay, so just know these lines are always going to be parallel. And then it says that the mid segment itself, DE, which I'll highlight over here in green, that is half of AC. So for example, if I know that AC is 10 centimeters, DE would be 5 centimeters. So that's the triangle mid-segment theorem. So let's get into practice with some of this stuff. It goes pretty quick. I don't know if I'll do all these. So in exercises 1 through 3, DE is the midpoint of triangle ABC. And know that midpoint means that it's going to make two congruent parts also. So for example, in this first one, mid-segment means AD is congruent to DB, and then AE is congruent to EC. And because it is the mid-segment of a triangle, this so happens DE is half of BC. So if BC is 28, I'm going to get that X is 12. So we're going to say 12 here. We cut it in half. Now, and number 2, if DE is supposed to be half of BC, if I take 15 and times it by 2, I'm going to get that my answer is 30 for number 2. Now, since DE is the mid-segment, that means that it cuts this other side into two congruent parts. So AE is going to be congruent to EC. That means X is equal to 9. So that's just what a midpoint does, okay? Because E is that midpoint. All right, let's look at number 4. It's a little bit of a longer problem. That's okay. So a couple different things here. It says the vertices of a triangle are points A, -5, 6, B, which is 3, 8, and C, which is 1, -4. What are the vertices of the mid-segment triangle? So what are the vertices? So it depends on which mid-segment you're looking at. So let's just graph this really quickly. I'm going to put my y-axis probably here in the middle. That should probably be good. And then my x-axis down here. And I'm going to tell you I'm already going to run off the graph. But if I go -5, 1, 2, 3, 4, 5, and then up 6, 1, 2, 3, 4, 5, 6. There, right here is going to be point A. And then point B is 3, 8, 6, 7, 8. There's point B, so that goes off the graph. And then C is 1, -4. This could be way down here. So there's 3, here's 4. So there's my triangle. Now it says find the vertices of the mid-segment triangle. So that means we want to make a triangle with the mid-segment. So first of all, we have to find the midpoint of all of these. Okay, so let's first find the midpoint of AB. So the midpoint of AB, remember that's where you're going to take your average x values, which is -5 plus 3 divided by 2, and then your average y values, which is 6 plus 8 divided by 2. And so we are going to get, oh, it's that, -2 over 2 would be -1, and then 6 plus 8 is what, 14 over 2, which is 7. So -1, 7 is my first point. I'm actually going to go ahead and graph that -1 and then 7. So here is my first one. Now let's find the midpoint of BC. So let's find the midpoint of BC. So that would be 3 plus 1 over 2, comma 8 minus 4 over 2, which is going to give us 2, comma 2. All right, 2, comma 2. I didn't connect BC very well, but 2, 2 is going to be like right here. And then last one, let's find AC. So the midpoint of AC, so that's going to be, what's that, -5 plus 1 over 2, and then 6 minus 4 over 2, which is -2, comma 2. So -2, comma 2, which would be roughly here. Again, I didn't graph that super great. I didn't use a ruler. So these are my vertices that it's asking for. And then if I graphed this triangle, that's the mid-segment triangle that it's talking about. All right. Let's look at number 5. Number 5, what is the perimeter of DEF? First of all, I'm going to find DEF really quick. Here's DEF. This is an important triangle to know which one we're looking for. And let's see what we have. So first off, the perimeter means add all 3 sides together. So I need to figure out the 3 sides. So let's focus on this 13 here is AB. And if I look at all the markings here, I see some congruent sides, or I mean, sorry, some congruent segments. So these are all going to be midpoints, which means we created mid-segments. So if 13 is AB, that means EF is going to be half of 13, which is going to be 6.5. So this right here is 6.5. If BC is 45, which is right here, DE is half of 45. So half of 45 here is going to be 22.5. And then if AC is 38, half of 38 is going to be 19. So if I take my 6.5 plus 22.5 plus 19 and add all those together, you will get your grand total of 48. All right, moving on to number 6. All right, in problem number 6, it says in the diagram, segment DE is a mid segment, so one of them of triangle ABC. So ABC is the whole big triangle, DE is the mid segment, and then it says FG is a mid segment of the smaller triangle ADE, and we want to find FG. So first off, let's just look at the larger triangle. Larger triangle ABC. If it says DE is that one's mid segment right here, so the one I have in red. If 52 is BC, DE is half of that, which means DE is going to be 26. So why does that matter? Well, what if I redrew now triangle ADE and FG is the mid segment? Well, DE is 26. FG is half of that, which is 13. So we can say FG equals 13. And you don't have to draw a separate triangle. I just did so you don't have the other one just like messing with your eyes. All right, the next number 7. If you were physically in class, I'd probably have pulled up a GeoGebra and showed you the following. So I'm going to draw something here. There's something special about the mid segments and a triangle. So here's my triangle here. If I look at the area of an entire triangle, it just so happens that that top little itty bitty triangle, the area is 1/4 of the whole thing, which means this little trapezoid here at the bottom is going to be 3/4 the entire area. Okay, so the triangle is 1/4, the trapezoid is going to be 3/4 of the entire area of the large triangle. So it says the area of the entire triangle is 48 centimeters cubed. Notice my denominator here is 4, which means we have parts of 4. Think about when we had our centroid, we had 3 parts, right? So we divided by 3. If I want to know all my parts here, I'm going to take that 48 and divide it by 4, and each part is worth 12 centimeters squared. Okay, that's each part. So what I'm going to do here now is, it says mid-segment, what is the area of triangle ADE? That is going to be the 12 centimeters squared. Now, if I drew the triangle the way they had it, then we could find out the polygon or that trapezoid that's on the bottom. You used to multiply that by 3 and get 36. Anyways, since that's not our question, let's just go on to number 8. This is the multi-part one here. So it's a little bit longer of a problem, just a little bit. Since the diagram below shows a triangular wood shed, you want to install a shelf halfway up the 8-foot wall that'll be built between the 2 walls. All right, so we have a vertical wall and then we have a slant over there. The vertical wall is 4 feet. The slanted part is 17 feet. Okay, now the first part is how long will the shelf be? So that means our shelf needs to be parallel to the floor. So here's our shelf, parallel. Parallel means it's going to be parallel down here. And it does say that they want this to be halfway up, which means if we put little congruent marks here, that means halfway would be 4 feet up this way. And if I had congruent marks over here for the next part, each section is 8.5. And the reason why we want that is to know, one, this is going to be a mid-segment, right? Now, for this mid-segment here, we want to know the length. So we want to find this length here. Now, oops, let's change colors in the middle of this. So what we have is we have a mid-segment. So if we know the bottom here is 15, this is going to be half. So that shelf is going to be half of 15, which is 7.5 feet. Easy enough, right? You don't do anything special. That's just our mid-segment theorem. Now, how many feet should you measure from the ground along the slanted wall to find where to attach the opposite side? Well, if we know a mid-segment is halfway, we already know how long to measure it, because if we want to get to this section, I'll do it in green up here. We want to get this point here, we have to go up the first 8.5 feet. So part B is going to be 8.5 feet. So not a long problem, just a couple different parts. And they give us a lot of extra space, not sure why. Anyways, there's the notes. If you have any questions, please feel free to reach out. If not, we'll either see you in class or you'll hear us on the next video. Have a good day.